Behind me is the wooden frame of our new project. In front of me are 9 tons of metal. Why do you need to combine 9 tons of metal when you're building a wooden frame? That's what we're going to talk about. When you open the drawings created by the structural engineer, you can see a lot of metal framing there. Why is this done? Of course, it all starts with the design. Now I'm going to show you inside the house. What was the reason for such a large amount of metal framing? The 9 tons of metal were needed in this house precisely because we created such a design. We are in the center of the living space. This is a huge space that won't have any internal support columns. This is exactly why we need to integrate metal beams, columns, and cantilevers into the wooden frame, meaning extensions that will go beyond the house. Since this space will connect with the outdoor area of the house. And here there will be the cantilevered awning covering the living space, outdoor area. And we didn't want to put in any columns to avoid blocking the view of the pool and other elements of the outdoor space. The project includes a wooden frame with the integration of metal I-beams. So those are the structures that support the cantilever, the extension that goes out front. Another element that influenced the integration of the metal frame, inside the wooden frame, this is the offset of the second floor of the house. Inside. So, the outer walls of the first and second floors do not align. Accordingly, the load on the beams that support the ceiling between the first and second floors specifically fall on the beams, not on the walls. And this adds additional load specifically on the beams. To strengthen these beams, the engineer installed special I-beams inside the house. In order for all these I-beams to work, for all the metal structures to function together, he wrapped the entire house with an external I-beam around the perimeter. What is an I-beam? I-beam is an I-beam, it's a design, it's a type metal beam. An upside down letter H with 2 verticals and a horizontal piece connecting the ends. This beam is very strong. It withstands any changes in the direction of the metal movement. It's very strong and holds up really well. Accordingly, he incorporated horizontal directions throughout almost the entire frame. The forces through the I-beam on which he places these I-beams, and he places them on the columns. Here we can see how the welders are already working on preparing the columns for the installation of the powerful I-beams with cantilevers. Here, the column used is 3.5 by 3.5 with a wall. 1/4 of it is installed on a special flange, the so-called MB plate. But here we use the MB plate, just like a regular plate, and anchors that are 10 inches long. This was included in the project, so you can get any information from the structural engineer's project. In this case, he installed 4 anchors, each 10 inches deep, which are drilled in and secured to the concrete. After that, a column is welded to this plate, and plates will be welded to the column. Horizontal connections, vertical connection, and the I-beam will be attached to this column, either through a weld or a bolt. In this case, we have both a bolt and a weld. This is specified in the project. On this side, the I-beam will be placed on top of the column. A plate was developed for this, onto which the I-beam will also be placed and welded all around. What does the beam provide? This beam extends 2 feet forward. The outer tie beam, which holds the entire structure together, will be shown in a video. After the whole structure is connected, we'll definitely show how it turned out. After that, wooden frames will be tied to all the metal structures. This will all be connected together. Metal, in this case, as in the human body, the spine holds the bones, keeping all the muscles around in a unified position. In this case, the wood starts to work together with the metal. Another reason why we had to use metal was the height of the wooden frame. In this case, the ceiling height will be 12 feet. It was the client's requirement. It's to have high ceilings, 12 feet, because high ceilings are being used. In some places, the tree has to be installed with a double board, sometimes even a triple one if there is support. For example, in this spot for the tracks aren't installed yet, so we can't see them. But high ceiling used tuba, 6 more than tuba for 2x4 used only for internal partitions. On all partitions where the tracks are laid, you will use tuba 6, sometimes even tuba 8. In this case, in this house, we've used tube, with X on all the external walls and on all the load-bearing walls where the beams are laid, plus metal columns in places where the frame extends beyond the house. The I-beams are laid on the metal columns. This I-beam also supports the load because there will be a window in this spot. And we have a lot of places where there are windows and the upper header uses an I-beam because the span is very large and the load on the window is significant. Also imagine in this spot, where the wall is, there won't be a wall on the second floor. The wall on the second floor is set back 3 feet and is practically resting on the beams. So when this is resting on the beams, it adds extra load to the beams. And this gives us the need to reinforce this with a metal frame. When I got the blueprints, I called our engineer Ryan and asked him, Ryan, why is there 9 tons of metal here? I thought it was supposed to be 10 tons of metal. Why is it 9 tons? He says, Igor, I've calculated everything. You have big spans, you have big cantilever overhangs, and the second floor is offset. You can't change that. If you want to build a house with this design, you have to use a metal frame. Here you see the beams. Fox sit 4x8. We specifically chose these beams to turn them into columns. To turn them into a design, you could just use regular posts, like 5x5 or 4x4. But in this case, it will be a design element. So, you see, the beams have already been purchased here, which will serve not only as support in the future, but also as a design element. In this working drawing, the red lines show where the I-beams will be, and the circles indicate where the columns will be. Here is the central beam, the 16th one, which is the main beam. It's practically supported by 3 pillars. And here the cantilever is almost 8 feet. This entire space is supported by, basically none of these beams have a supporting column. They are connected in a T-shape to the column with this beam. But this T-shape can't just hang in space. So he created a support point at the connection. Here and here, this point is also supported by the cantilevered columns of this T-shape. T, and this point is supported thanks to the ready-made solid structure under the canopy. And so it all connects into a single chain. It's a single connected chain, and this way it supports this main beam. The entire connected chain runs around the perimeter, and the floor, as you can see, is the second floor. It's a bit hard to see here, but there it is. It goes inside. It doesn't rely on the walls like in classical architecture. Here is the inner floor. It's a little smaller than the outer one, so there are also supports on the metal beams. And here and here and here and here, it's all... The design has been pre-calculated by the engineer, which is approved and has a stamp, and then the engineer will make his report after we weld everything of his own. A report after we weld everything. I want to talk a little bit about the workflow. Sometimes they put up the metal frame first and then install the wooden frame and tie it to that. I took a different approach. First, we set up the wooden frame with our framers. What did this give us? This gave us clear positions for the pipes where they need to be installed. This gave us a clear height for the entire first floor. And now when the welders are working, it's pretty easy for them to orient themselves up the ends of the first floor, and they can calculate very easily the sizes of the columns, the dimensions where the top of the I-beam should be, and the bottom of the I-beam. We also have the intermediate I-beam that runs inside the routs. This is already quite big. 16-inch I-beam, and it hides inside the tracks. This is the placement of the wooden frame. It gave us a clear understanding of how to install it, because when you look at the drawing, you just see a plan that just says where your beams are, where the roots are, and what materials are being used. But you have to calculate it yourself based on the architectural drawing. And this approach that I used first installing all the walls, interior and exterior of the house, and then bringing in welders to weld the whole frame turned out to be more effective. Look, I'm talking about the dining area, and here's the island. First of all, the island will be from here up to here. This is the island, just 4 meters long then. There's a long table for the whole big family. They have a big family, about 10 people, different ages. There's a small dining area, like when you're having breakfast. After, this is the dining area, and then the sitting area, then 2 sitting areas, and next to the fireplace, there's the fireplace. More. So this is the fireplace area. There will be a hole here, and here's the bar, right under the stairs. Here's the bar. Here we've run the pipe. This will be the bar under the stairs, and there will be a pantry space, that is. Next. Then all the big sliders open up, and you step out onto a large platform to create one unified space. We had to install an I-beam that runs all the way, from one side of the house to the other. And it extends almost beyond the limits to 10 or 12 feet forward. Naturally, 10 feet can't hang without a column. In order for the column to hold, we had to connect that wall and this wall with another I-beam. And it already forms the letter T. To make sure those I-beams were secure, we had to wrap the entire house with an I-beam around the perimeter. And then it becomes a solid, unified structure. And it allows us to keep everything in this interior space column-free. And outside, we won't have any columns. We only have a few places in the house where we used columns. But they were designed as a design element. We'll show you. In this video, there's a separate photo where 3 columns stand together as a design element. When you have to use columns and can't avoid them, make them a design feature. Don't just put one support column, for example, 2 or 3 or 4. It will already look like a design element. Metal allows for that. Metal allows for beautiful structures that are design elements, not just a wooden post or a metal post. If you're building a house to sell, that's always a selling point. How did you incorporate the column? Is it there or isn't it? Is this a design element? Or is it just a post that was put on a wooden floor holder and that's it? And they even forgot to paint it. I've seen such horror on houses. 6 million, of course. It's impressive. In the opposite way, you don't understand why I should pay 6 million when I have this. In the center of the outdoors living space, there's a wooden column that isn't even painted. Today's architecture requires large window spans. People love to integrate the indoor space with the outdoor space and vice versa. Especially when you're building a house in the woods or with a beautiful view, you'll definitely want to have large windows. In this case, these windows are 12 feet tall. And the length of this span is about 20 feet. How to do this with wooden framing is practically impossible. In this case, metal support columns will almost always be used. And the I-beam in the form of a header. This is necessary so that the beam doesn't sag and doesn't put pressure on the central doors. There will be a slider door here. If you make a wooden beam, most likely it will sag over time and put pressure on the inner part. Windows and the slider doors will not operate smoothly. Therefore, here I would even recommend not to save money, talk to your engineer, and install a metal one. I-beam, this will allow you to have a straight line, and you'll never have problems with the windows in the center. We have a couple of houses where we encountered this issue. With this problem, we found a solution to fix it, but it took extra time and money to resolve this issue. Right now, I'm emphasizing this point always. How to make it so that the central part doesn't sag, and this can only be achieved with a reliable I-beam. Let's talk about the cost. The cost of such a frame will, of course, be higher. In this case, the house is 5,000 square feet, where we had to use 9 tons of metal, which cost us an additional $45,000. To reinforce this frame, with wood, we spent another $50,000, plus $50,000 for labor, which totals $100,000. So we add that, we go to $145,000. The frame costs for 5,000 square feet. Who you need for the job, you definitely need framers who will work with the wooden frame. But you will also have to find a team welders who can read your drawings and do quality work. And after the metal work is done, you'll need to pass an inspection. Let's talk about the inspection. You'll go through 2 inspections. The first is the city or third-party inspector who will check your frame. And the second is the engineering inspection, meaning the engineer who prepared the blueprints. He needs to come to the site and check how all the welds are done, all the connections, bolts and anchors. So he checks and prepares the engineering report that you attach to the documents. This means that the frame is done correctly. And when you apply for the warranty, you'll be asked for a similar engineering report. Based on this report, they will issue the warranty and calculate the price, how much it will cost. The builder's warranty that you purchase. So let's summarize. When is a combination of a metal frame and a wooden frame used? If you have an original design in mind, in cases where you don't want to put up columns, in cases where you want to have a high ceiling and avoid any columns inside the room, making the space larger. You'll have to deal with a metal frame that integrates into a wooden frame. It's not that difficult, it just adds a bit of effort and extra costs. But in the end, you get a unique design where your client will enjoy a large open space. And you won't see the columns that support any cantilevered structures covering the outdoor living space.